Video number 115, graphing a parabola, a horizontal one, by completing the square. Alright, so what we're going to do here, guys, is we're going to take out this a value, and when we're going to do this, we're not going to do a traditional factoring. We're actually only going to factor the first two. So one of the things you could do is you could start off by grouping the first two terms. We're going to leave the 3 alone. Even if 3 was an even number, we would still leave this 3 alone. It's not because the 3 is odd, and you'll see hopefully in the next example that emphasized even more. So we take the negative 2 out. Now this is just one way to do this. I think this is the best way to do this. So you just factor out the first 2, you take out the negative 2, you're left with a positive y squared, a negative y, and then of course a minus 3. What you do is you reverse engineer this. You don't have to think about this as factoring. Reverse engineer. What you do is you take a 2 out of the first 2 and just multiply it back and see if you get the original. And of course, if you multiply this negative 2 back, you're going to get exactly this because the 3 is not going to be affected by the 2. Then what you do is you try to complete this square. So you take this 1 and you divide it by 2 and then you square it. That's going to be 1/4. So what you do is you add 1/4 to make this a perfect square. Well, let's go through the logic for a moment. Right now, we just basically put a plus sign and a 1/4 right here in order to complete this perfect square. Okay? Now, looks like this is 1/4 with a plus sign, but it's all being multiplied by the negative 2. So what we really did here is we added a half. We added a negative half to the right side of the equation. Here's the equation line right here. We basically just added a negative half. In order to stay balanced, you either have to add a negative half here or add a positive half over here. So what we do is, this is really a negative half, so to stay balanced, if you will, we're going to add a positive half right here. There it is. The next step, this trinomial becomes a perfect square binomial. The negative 3 plus the half becomes negative 2.5. You got a negative 2 in front. Where's the center? Okay, and then we're going to go through the steps that we just did in video 14, because this equation is basically just like what we had in video number 114. All right, copy it down. I forgot to put the squared here. Nice, this is nice. All right, then we have a positive half for y, gives us a negative 2.5 for x. Okay? That zeroes out, the positive half zeroes out the y, you just go through the steps. Then you go 1 away from 0.5, that's 1.5 and negative 0.5. Plug those both in, you get plus or minus 1 here. Square that, multiply by negative 2, minus 2.5, negative 4.5, bam, for when y is 1.5 negative half. Then we're going to go what? 2 away from 0.5. You know the theme here. The 2 away gives you a plus or minus 2 squared. What's 2 away from 0.5? 2.5 and negative 1.5. 2 squared is what? 4 times negative 2 is negative 4.5 minus, 4 squared. Plus or minus 2 squared is 4. 4 times negative 2 is negative 8 minus 2.5, negative 10. Negative 10.5, comma 2.5, negative 10.5, comma negative 1.5. Alright, then we're going to throw those bad boys on a graph, and we will then have the correct graph. So negative 2.5 comma half, to the left negative 2.5, up half, puts us right here. Negative 4.5, up 1.5. To the left 4.5, up 1.5, that'll put us right here. To the left 4.5, down a half. Right here. To the left 10.5, up 2.5. And right about here. To the left 10.5, down 1.5. And right here. So there it is. So as you can see here, as you were going to summarize, as you can see, look at what you got here. You got an x equals the y squared. Remember what that mother graph is. It's an east-west graph. Why is it going to the left? Well, bam, right here, the negative 2. All right? So that's pretty much how this all works out. Here's another example. X plus 3y squared plus 18y plus 22 is 0. What you do is you move all these guys over to the right side. All of them are negative. Take out a negative 3 only from the first 2. Leave the 22 alone, okay? Then you're going to complete this square. That's going to be a plus 9. But what did you really do? what did you really do? It's a plus 9, but it's really what? Minus 27. So to stay balanced, we added 27. This way here we added 0 to the right side. And then now you have negative 3 times y plus 3 quantity squared plus the 5. This is an easy vertex problem from here. Negative 3 for y, 5 for x. There it is, 5 for x, negative 3 for y. 1 away from 3 is what? 2 and 4. Bam, you go through the numbers, you get 2, 2 comma 2, 2 comma 4. 2 away from 3, 1 and 5. 2 squared, 4 times 3 is negative 12 plus 5, negative 7. Bam. And then just throw those bad boys on the graph. 5 comma negative 3. 2, 2, 2. Wait a minute here, I did something wrong. Is that 2 negative 2? No. That's right. 2, 4. 5 negative 3. 5 negative 3. What did I do wrong? What did I do wrong? What did I do wrong? Oh, let's go back. Let's go through the numbers here. Let's make sure we complete the square right. Negative 3 for y, 5 for x. Oh! We were supposed to do what? We were supposed to go 1 away from negative 3. That puts us at negative 4, negative 2. So, and I think everything matches up pretty good here. So we're at 2, negative 2, 2, negative 4. Let's see here. 2, negative 2, and negative 4. Yeah, that'll give you a plus or minus 1. Yes. So that'll be a negative 3 plus 5. That's 2. Okay, those are good. Those are good. Then what? 2 away from negative 3 is negative 1, negative 5. Plus or minus 2, that's going to be 4. That's a negative 7. Okay, good. So now we just need to call these negatives, and we should be all set. It's actually good to make the mistake in front of everybody, because then we can see how you can correct it. So I knew something was wrong when I had this, because that's supposed to be the vertex, and it is. So 2, negative 2. That'll be over here. 2, negative 4. That gotta be right here. Negative 7, negative 1. It's negative 7, negative 5. So yeah, so that's actually, I think, I mean, some people can criticize me all they want, but showing how to find out where you messed up is a very important thing for students to understand. We knew that this wasn't going to work because the vertex was here, so we were going to either go this way or, of course, north-south. We knew it wasn't north-south because this is an east-west shape. We knew it was going left, so it was just a simple negative. So yeah, anyway, good times, guys. Good luck, and talk to you later.